So here's some of the comparison operators. We've sort of brushed on these, but just to kind of officially state, typically the double equals is an equal comparison, whereas a single equals is, I think it's called like a set operator. So the double equal says on the left expression and the right expression, are they equal? And the exclamation point equal is not equal. So not, exclamation point typically means not equal. The less than, you remember that. The Pac-Man goes towards the bigger number. Less than, then less than equal to. Greater than equal to.
Now the not equal symbol, the bang equals, exclamation point equals, generally speaking is in most languages, but this is the symbol that sometimes varies from language to language. Sometimes this is represented as a less than, greater than.
Yep. Like in SQL, it's like that.
Right.
Some SQL implementations. There's also
and basic and
like Perl is like NE.
Yes.
And also Perl equals EQ. Mm-hmm. So some languages it does vary.
But for the most part, this is what you'll find.
Mm-hmm. And also the double equals is valid in some Perl expressions, but I think it's when you're evaluating strings that you have to use EQ. So it can kind of go both ways. So as we talked about in the last slide, here's some examples of some comparison expressions. Does 3 equal 3? Well, if you look in the right column, that's false, because that's not a true statement. 2 times 2, which is 4, is less than 1 divided by 2, which is 0.5. Well, that's just flat wrong. That's false. That is not a true statement.
Obviously.
So now we have 9, now order of operations, people. 9 times 1, which is 9 minus 3. So that will be 6, right? 6, 7, 8, 9. Perfect. So 6 is less than or equal to 7 minus 1, which is 6. That is a true statement, so it's true. 2 mod 2 is less than 2. That is also a true statement because 2 mod 2 is 0. Because remember our example from before, when you divide 2 into 2, it's 1.0. 0.0 times 2 is 0. There's your modulus. Next, we have 1 plus 4, which is 5 is less than or equal to 100. Looks true to me. And next we have 2 times 10, which is 20, does not equal 20, and that's just flat wrong. I can't even believe that I actually typed that. So there are some examples of using some comparison operators.
Lastly, we have logical operators, and we have the OR and the AND operation. So the double bar symbol is the OR operation, and the double ampersand symbol is the AND. So in this case, we have if truth, or something and something. So let's look at some comparison expressions. Here we have 10 equivalent to 5, which is false, or 10 less than 100, which is true. So in this case, it's either false or true, and since it's an OR operator, only one of them must be true, so the final comparison result value is true. And you can see that on the right with the false or true results in true. In the second condition, we use the AND operator. So 10 equivalent to 5 is false, ampersand, ampersand, or and in parentheses, 10 is less than 100, which is true. So in this case, we have false and true, which, because it's the AND operation, we need a truth and a truth. So this results in a false value.
Just as a heads up, when looking at this, pay close attention to our bitwise video, because of these bitwise expressions directly relate to how computers make these decisions.
Absolutely. So at this point, you should really know how the OR and AND function. But for this language and a lot of other languages, the OR is the double vertical bar and the AND is the double ampersand.